Have you ever wondered how we can know so much about stars and galaxies millions of light years away, when we can't even touch them? The answer lies in the language of light, a fascinating field of study called spectroscopy. It's akin to a cosmic detective story, with astronomers playing the role of Sherlock Holmes, unraveling the mysteries of the universe. Spectroscopy, at its most basic, is the study of how light interacts with matter. When light from a distant star or galaxy reaches us, it carries with it a wealth of information about the object that emitted it. It's like a cosmic fingerprint, unique to each celestial object. But before we delve deeper into spectroscopy, it's crucial to understand what light is. Light, or more broadly, electromagnetic radiation, is a form of energy that travels in waves. These waves can have different lengths, and the length of the wave determines the type of light, from radio waves at the longest end of the spectrum to gamma rays at the shortest. When light passes through or bounces off an object, it can be absorbed, reflected, or refracted. Each of these interactions leaves a mark on the light, altering its color or intensity. By analyzing these changes, astronomers can glean a wealth of information about the object that the light interacted with. This is where the power of spectroscopy comes into play. By splitting the light into its constituent colors, a process known as dispersion, astronomers can examine the specific wavelengths of light that an object absorbs or emits. This forms a unique pattern, known as a spectrum, which can be used to identify the chemical elements present in the object. But spectroscopy doesn't stop at identifying elements. It's also a key tool in understanding cosmic chemistry, the study of chemical reactions in space. For instance, by examining the spectrum of light from a distant nebula, astronomers can determine not only what elements it contains, but also the physical conditions, such as temperature and pressure, that prevail there. This can provide crucial clues about the processes that lead to the formation of stars, planets, and even life itself. Now you may be wondering, how do we know which elements correspond to which spectral lines? The answer lies in the laboratory. By studying the spectra of known elements here on Earth, scientists have been able to create a reference library of spectral lines. When they see these same lines in the light from a distant star or galaxy, they can confidently identify the elements present. To summarize, spectroscopy is a powerful tool that allows astronomers to study the universe in ways that would be impossible otherwise. By analyzing the light from celestial objects, they can determine their chemical composition, physical conditions, and much more. It's like a cosmic detective story, with light as the language and spectroscopy as the key to deciphering it. So, the next time you look up at the night sky, remember that each point of light is telling its own unique story, and thanks to the power of spectroscopy, we're able to listen and understand.